Subscribe now and press the bell icon. Never miss an update.
First, our paper is one-sided Schmitt-trigger-based 90 SRAM cell for near threshold reoperation. Okay, in this paper, a one-sided Schmitt-trigger-based 90 SRAM is implemented. So, on implementing this, what we achieved means we are achieving the low energy consumption and with high read stability. So, how do we achieve these things? Let's go and discuss in this. So, in this, the proposed Schmitt-trigger-based 90 SRAM obtains a high read stability by using a one-sided Schmitt-trigger inverter with a single bit line structure. As the name it indicates, it is one-sided. That means it indicates with only single bit line using. So, and in this, the applications must be as bioplants, mobile devices, self-powered wireless sensors, and energy harvesting devices, because they operate with a limited energy from the battery or harvesting. So there are so many ways to reduce the power consumption or energy consumption. So the most effective way is to reduce power by scaling down the voltage. So even though the delay and soft error rates increases by it. So the next approach is in the subthreshold region. So what is subthreshold means? In the subthreshold, VDD is lower than the VTH. By that, the delay increases and also energy consumption also increases. Okay, so by this disadvantage, we are going to operate in near VTH. So what is the difference between the near VTH? In near VTH means the VDD value is slightly higher than VTH. So by that we can achieve a larger power reduction compared with a sub VTH operation. Okay, and so in the near VTH region, the transistor current is highly susceptible to VTH region. So for a particular SRAM cells, they are affected to the VTH variation because they should be designed with small size transistors for high density in a limited area. So various SRAM cells have already been proposed with the near threshold region, but there are some drawbacks like a write-back scheme for bit interleaving structure, SRAM cell size, or high energy consumption like that. So in this, we proposed a Schmitt-trigger 90 SRAM cell that uses a bit interleaving structure without write-back scheme and has a low energy consumption. Okay, and there are the three features to achieve this. In this paper, we are achieving the three things. Improvement in read stability. So improvement in read stability, how we are achieving means by using the cross-coupled structure of the standard and ST inverters. So, and the second one what we achieve means reduction in energy consumption. So how it happens means by using a single bit line structure. And the third one is the writability improvement. So how we improve the writability means by selecting a power gating technique with ST inverter. These are the three things we are achieving by implementing this paper. So let's go into the operation. So in the proposed ST90 RAM cell has a cross-coupled structure of the standard inverter with the stacked transistors. So what is the stacked transistors? Means the transistors in series. The transistors connected in series is nothing but a stacked transistors. So here we can see that PUL1 and PUL2 are in series connection, and PDL1 and PDL2 are also in series connection. So these are the stacked transistors we can see. So and an ST inverter also we are using. So what is the ST inverter here using? Here there is a schematic of the ST inverter. Here this is the structure of the ST inverter. So what is the use of ST inverter means we can discuss in detail here. Okay, and this is the structure of the Schmitt-trigger 90 ST90 SRAM cell. So here we have to give the inputs in this manner only. So by that we are able to observe the waveforms very clear in a clear manner. Okay, and this is the structure of the ST90 SRAM cell. Okay, yeah. So how we will go, how the read operation operates means we can see here. Okay, and in this I forgot to share you one thing, that ST inverter using PUR, PDR1 and PDR2 and NF and one NMOS PG. So PG is nothing but a power gating, and these three are the and ST inverter. Okay. And next, in that also, word line WL is a row based signal, WWLA and WWLB are the column based signals. Once we can see that WL is a row based signal, here WL is a row based signal, and WWLA and WWLB are the column based signals. Okay. Next, so read operation. So in the read operation we can observe that WWLA and WWLB are 0 and 1. So we can able to see this. So that is the hold condition. At these conditions WWLA is 0 and WWLB is in 1 condition. Okay. And next, for the read operation, WWLA is 0, WWLB is 1. Okay. This comes under the read operation. Okay, and the next, for the write 0 operation, for some time the WWLA should be 1 for some instance, and later on it is decreased to 0, but WWLL it seems to be the constant. So what is this reasons and how it operates also now we will see. So okay, now in the read operation we will now we show that WWLA and WWLB are 0 and 1. Now I am placing the signals. Okay, now I am placing WWLA as 0 and WWLB as 1. Okay. And by this PUL2 and PDL2 PDL1 are turned on respectively. Okay. By giving this, what will happen? By giving 1 means, as this is a NMOS transistor, this comes under on. Okay, as giving WWLA as 0 means this also comes under on condition, and by this we can see that okay, both are in on condition. At the same time the storage node Q is driven by the standard inverter. So at the same time WL is enabled, enabled and PG is turned on. That means here we are giving WL as 1. 1 means this PG transistor is also turned on, and whatever the BL is comes to the Q. That means here the read operation is verified. So after it is getting means here it is given to the inverter. Based on this output we are achieving the QB value and QB value. So then the BL is discharged or not depending on the value of the node Q. The proposed ST90 SRAM cell solves the read failure. So what is the read failure we are facing here means, so read failure is caused by a read disturbance from the BL. Similarly, it has a double-ended using double structure of the BL. At that instances read failure is commonly appears. So when the storage node is bumped by a read disturbance and the voltage of the storage node exceeds the trip voltage of the inverter, the storage data can be flipped. It means when the storage node is disturbed means the data at the storage node will be flipped. So by using ST90 SRAM cell we can avoid this condition. Okay, and this is the one of the advantage of this of implementing this paper. And now from the figures 3 and 3, when the input voltage Vin transmits 0 to 1, the ST inverter has a higher trip. Depending on this one, as simple it is, it comes under the 0 1 only, but here there is a feedback used of NS. So what is the need of this? Now we can see that this is the basic, because the strength of the PD1. So here the strength of this PD1 is weakened by this Vx. As the voltage here increases means it can cause the reverse biased condition. So by this Vx increased through the feedback transistor NF, then the storage node is bumped by a read disturbance. the ST inverter is more robust to read the read disturbance than the ST inverter. So when it falls comes under Vx voltage is increases, means at the time read failures occurs. By using ST inverter we can avoid such instances. So on by looking into this explanation up to now, we can say that read stability is improved by using the ST inverter. Okay. And coming to the write operation, so here the write operation differs depending on the written data. So what is written? Okay, so it shows here write 0. There is a different operations for write 0 and to write 1. So during the write 0 operation, the column based WLLB remains 1 and WWLA drives to 0 and the W is enabled. So as the column based WWLA is changed to 1, to disconnect the path from VDD power source by turning off the PUL2, node Q storing data 1 is power gated. That means here already we discussed that for some time here we are achieving 1 and later 0. So why it is disconnecting to 1? Disconnected means to disconnect the path from VDD. Okay, see here it is clearly mentioned that is changed to 1 to disconnect the path from VDD power source by turning off PUL2. By that the Q storing data 1 is cleared. It is clearly mentioned here. So coming to the write 1 operation also, WWLA remains 0 but WW drives BL to 1 and WL is enabled. As WW changed to 0 means to disconnect the path from the VSS, that means ground. So by turning off the PDL1, and here also the node Q storing data is power gated. Okay, so this is the write operation, read operation and the hold operations in the 90 ST SRAM cells. Up to now we can implement this in this paper. Okay, from this we can say that read stability is improved and write stability is also improved by using ST inverters and cross coupled structures of the ST inverter. Thank you.